This video is designed to help you understand how the T53 multi-purpose frictional wear tester works and how we switch between different test configurations. The T53 works as both a sliding block-on ring type tester and as a fixed slide roll ratio to roller machine. The machine has two shafts. The lower shaft is in fixed bearings and the upper shaft is gimbal mounted at the non-specimen end, facilitating load application and friction measurement. Sliding test configurations include cross cylinder, block on ring and ball on cylinder. Two roller configurations include both line contacts with flat roller on flat roller and elliptical contacts with a crown roller on flat roller. We're going to start with the sliding contacts. A simple screw mechanism is provided for raising and lowering the upper shaft. A transparent cover provides access to the test assembly. To remove the upper specimen carrier, release the nut holding the carrier onto the upper shaft. You can screw in a couple of cap head screws to help with the removal process. The lower roller is secured to its shaft by a couple of cap head screws. The block specimen can be removed by loosening or removing the clamping block. A grub screw is provided for tightening the specimen against the block. A new test roller can be installed on the lower shaft and clamped with the two cap head screws. The upper specimen carrier incorporates a spherical bearing to aid automatic alignment of a line contact, in other words a block specimen, against the lower roller. The self-aligning feature can be locked out if required by securing the upper specimen carrier to the shaft mounting flange. This is done when using ball-on cylinder or cross-cylinder test geometries. Ball specimens are mounted in the upper specimen carrier and clamped using the grub screw. As the self-aligning feature is not required with a ball-on cylinder test geometry, the upper specimen carrier is clamped, disabling the self-aligning feature. The same applies to the cross-cylinder test geometry. Let's now move on to the two-roller test arrangement. The lower roller is fitted as before. For a self-aligning roller contact, the upper roller is flat with a spherical bearing at its centre. For an elliptical contact, the upper roller has a crown surface and is clamped against the shaft flanges with a pair of cap head screws. We're now going to explore the driving end of the machine, starting by removing the guard. The current drive setup is for sliding tests. The upper shaft is prevented from rotating by a sleeve that fits in the same plane as the gimbal bearing. A pair of removable pins prevents the sleeve from rotating. Once these have been removed, the sleeve can be replaced with a gear, turning the machine from a sliding block on ring unit to a 2-roller machine. To change the slide roll ratio, both gear pairs must be changed. The drive belt must be loosened and the pulley on the lower shaft removed. It's held in place with a taper bush. A special tool is provided for holding the roller end of the shaft, allowing the nut to be removed from the gear end. A different slide roll ratio gear pair can then be fitted. The pulley replaced, the belt refitted, tensioned, and the taper lock finish tightened. Before we refit the guard, we need to apply some grease to the gears. For completeness, we're now going to show how to go from the 2-roller setup back to the sliding setup. The upper gear is removed. The anti-rotation pins refitted. And the upper shaft clamp sleeve fitted. Full details of the T53 can be found on our website. Alternatively, you can contact us direct at Phoenix Tribology for further information.